Grade 10s, welcome to the last show of this term. I'm sure you're excited about some holidays, and I'm sure you're excited about all the practicing that you're going to do during the holidays. Remember, the mind is a machine, it's a muscle that needs to be worked, otherwise you're going to forget everything. And trust me, you will. And you'll only remember in a test that you've forgotten everything, and by that stage, it's gone. So, today's lesson, we're going to go over everything that you've done before, but we're not going to give you notes or anything like that. We're actually just going to go over the questions. So before we begin, let's look at what you have done. Now, you started off the term with algebraic expressions, and then you moved on to exponents. Very, very closely connected, the two of them. Then you did some number patterns, and we looked at all sorts of different number patterns and how to work with them. And we did some equations and inequalities, and those are also very closely connected to these. And the reason they're all so closely connected is because they all require algebra to do. So those all, I spelled algebra wrong. So they all require algebra. Then last week we looked at some trigonometry. So we're going to do questions that are about all of these different things. And these questions come from the challenge questions that you've been getting every term. Now I know that you have been doing them not every term, every show. I know you have been doing these questions as you've been going along, so you don't need any extra time to do them, except for this first question. This first question is going to be new. So I'm going to give you 3 minutes to write it down and start attempting it, and then we're going to try it together. And here it is. It says, simplify the following algebraic expressions. So grade 10s, you now have 3 minutes to write it down, attempt it, and then we'll do them together. Now you'll notice that all of these questions contained fractions, and what do we call fractions? They're grannies in bikinis. They're things that are lovely and fun to do and be with, but they're ugly to look at. So you need to get over that feeling of not knowing what to do with fractions and just deal with them as you would your favorite granny. Okay, let's start with the first one, and we'll call up a screen. And we've got a binomial multiplied by a binomial, which means that we're going to use FOIL when we multiply it out. And remember, that means we're multiplying the first two terms together. What is x times x? It's going to be x squared. And then we're going to multiply the outside term. So we multiplied the first, now the outside. And x times by 1 over 3. When we multiply fractions, we multiply the top with the bottom. Oh, how did that equals get in there? We multiply the top with the top and the bottom with the bottom. So that gives us 1 over 3 times by x. Then we're going to do inside, which is negative 2 over 3 times by x. And then we're going to do last. Now, I like to think of multiplying fractions as friends hugging. There's the one friend and there's the other friend. Look, they're reaching out to hug each other. And there are their fraction lines. Their heads are going together and their feet are going together. So that means when we multiply negative 2 over 3 by 1 over 3, they're hugging. So the negative 2 multiplies by the 1 and the 3 multiplies by the 3. So that gives us negative, what's 1 times 2 is 2 and 3 times 3 is 9. Okay, we do have like terms that we can add. There they are. So let's add them quickly. We write down the x squared, nothing we can do with that. A third x minus 2/3 x is going to be minus 1/3 x. And now we can simplify the last fraction to be minus 1 over 3. Okay, grade 10s, that wasn't too bad. It was just the fractions that might have made you think, I don't know what to do here. But I know you coped fine. Remember, multiplying fractions is like friends hugging. Shall we do the next one? Okay, the next one, we've got fractions that are dividing. Now let me tell you, we don't like dividing. No to divide. No, no. So there's my little protest sign. So we're going to change it to a multiply. And that means if we're changing it to a multiply, the fraction is going to flip around. In other words, we're multiplying by the inverse, or the reciprocal. There we go. What can you tell me about this fraction? There's not much we can do with it as it currently is, because this numerator is just ugly. What can we do to neaten it up? I hope you said factorize, because that will certainly neaten it up. And remember, we can take out a common factor, we can do a difference of two squares, we could do a trinomial, or we could do a difference of two cubes, or a sum of two cubes. So those are our options for factorizing. In this case, we're taking out a common factor of 3x, and we're left with x minus 2. Whoops, I had to squeeze it in a bit there. There's not much we can do with the 6x at this point. But now we can cancel. Look, that down there can cancel with this up here. Grade 10s, I need to emphasize that the only time you can cancel when there are two terms in a numerator or a denominator is if you cancel it as a whole value. You must cancel it together. Think of that plus or that minus as a kid holding on to sweets. So if you've got a younger brother or sister, you'll know what I'm talking about. If they've got a sweet, they're generally not going to give it to you, especially if you're mean to them. So the only way you can get rid of them to get the sweets is actually to get rid of the sweets with them. So it all has to go together. Okay, we've got some other cancelling we can do here. I haven't quite finished. So let's go back to it. And you'll see we've got 3x and 6x. The x can cancel with the x, and the 3 cancels with the 6, but that leaves us with 2. So what we have now, and let's rewrite this neatly, is 1 over 2 times by 4x squared over 1. Oh, I have some more cancelling I could do. I could have done this in the other step. The 4 can cancel with the 2. Now the reason this can happen is because anything in the numerators can cancel with anything in the denominators as long as the fractions are being multiplied by each other. So that means we have a final answer of 2x squared. Okay, let's go to the next screen where we have the last question. Now, I actually thought this one was a little bit difficult because it asks you to remember that there are 2 different terms here. And our terms are always divided by a plus or a minus sign. So that's how we know that there are 2 different terms. You've also got to remember that you need to do BODMAS first. So you must do brackets. There are no brackets, there's no of, but there is a multiply. So we're going to start by first multiplying this, and we're going to ignore the other side for a while. So when we multiply fractions, we multiply the top with the top and the bottom with the bottom. And remember, it's like friends hugging. So you bring it in and you give a good squeeze and your heads are together and your feet are together. So we're going to do that. But before we do that, can we factorize this? The way I know that I need to look for factorizing is there's an x squared and there's more than one term in the numerator. So let's look. I've got x squared minus 1. And if you saw that that is a difference of 2 squares, you would be absolutely correct. And let's put it over the denominator of 3, and it's being multiplied by 1 over x minus 1. Now you remember that the only way we can cancel 2 terms in a fraction, let's just put the other term in, is if we cancel them together. So that can cancel with that, and now we are left with a multiplication problem of x plus 1, and I'll keep it in brackets, over 3 times by 1 over 1. That feels a bit silly, doesn't it? Because 1 over 1 is actually 1, and whenever we multiply anything by 1, it actually stays the same. So let's just leave it out. Why? Because we're mathematicians, and mathematicians are well known for taking the easy way out. Now, we are going to extend this page, and there we go. And we're going to subtract these. The problem is these denominators are not the same, and when we subtract fractions, we need them to be the same. So I'm going to change them to a lowest common denominator of 6. That means this fraction gets multiplied by 2 over 2, and this one gets multiplied by 3 over 3, giving us 3 over 6. So our final answer will look something like this. 2x plus 1, let's get rid of that dot, minus 3 over 6. I can multiply it out. It's not going to do anything mathematically. So you could, oh, scroll for me, baby. There we go. You could leave it like that, or you could, oh wait, it does do something. Because now I can add that 2 to that negative 3. I take it back, multiply it out, go forth and multiply. And we've got 2x minus 1 over 6. Grade 10s, how did you do? Was it good? Do you think you're ready? Okay, we're going to take a break, and then we're going to get to the next question, which is from the exponents show. And that one was exciting. We'll see you just now. I hope you're feeling nice and relaxed after that break, because this next one is a typical exam question. And I've seen it in grade 10 exams, and I've seen it in grade 11 exams. I don't think I've seen it in a grade 12 exam. But the point is, it's good to get to know it now. Okay, so let's take a look. We have a fraction. In the numerator, we have x to the power of -1 minus y to the power of -1. And then in the denominator, we've also got two terms that are subtracted from each other. Now, the first thing I'm going to do is decide what is disturbing me the most. Because if I decide what's disturbing me the most, I can get rid of it. So I'm going to circle it in red. I don't like that, I don't like that, that's ugly, and that's ugly. And maths is all about making it easier. So I'm going to change those to fractions, starting with x to the -1, which becomes 1 over x, minus y to the -1 becomes 1 over y. And don't freak out now, but that already looks a lot easier. Trust me on this, you'll see. And then at the bottom, I have y over x minus x over y. Okay, grade 10s, what we have now is something called a nested fraction. And a nested fraction are fractions that are within fractions. Now, often this can look confusing to most people, so what I suggest you do is, because it's making you feel uncomfortable, don't write it as the fraction over the fraction, write it as a fraction divided by a fraction. And then later on, we can change it to multiply. Remember, maths is all about making it easier for you. So do it the way that makes you feel good. Okay, let's write that now. Let's just scroll down. And it's going to be, I'm keeping it in brackets, 1 over x minus 1 over y divided by y over x minus x over y. Now, I haven't done anything mathematical. I've just made it look different to what I had before. Now I'm going to work with the individual brackets, starting with this first one. If I am subtracting fractions, I need to have a lowest common denominator. And my lowest common denominator in this case, let's write it to the side, is xy. And this will just make my life a lot easier. So I'm going to put it all over xy immediately. And then at the top, this becomes y, and this becomes x. Not too bad, hey? Now in the other one, I also have a lowest common denominator of xy. And because I'm multiplying the first fraction by y over y, the first term becomes y squared. And the second one, this one, I'm multiplying by x over x, which gives me x squared. So grade 10s, now we have a fraction divided by a fraction. And remember, we don't like dividing fractions. No to fractions, or no to dividing them. So we're going to change it to a multiply, and when we change it to a multiply, we're going to flip the second fraction. And this will make it a lot easier to work with. And remember, maths is all about making it easier for yourself. So I'll start by writing the first fraction again. Let's just scroll up. I have y minus x over xy. And the other fraction changes to xy over, oh, I want to pause over here, because look over here. What do I have? I have a difference of two squares. So let's do the difference of two squares. It's going to be y
minus x and x, oh, not x, y plus x. Okay, let's just draw a pink line in here so that you can see that that definitely comes from that.
There we go. Okay, now remember grade 10s, multiplying fractions is like hugging a friend. Your heads go together and your feet go together. So when you multiply a fraction, you multiply the top by the top and the bottom by the bottom. But we always look out for things that we can cancel first, because maths is all about making it easier, and if we can find ways to not multiply, then it's all good. Let's take a look.
Okay, now in this first fraction, our top term is y minus x, and that of course cancels with y minus x over there. And our numerator, or our denominator, is xy. And that, of course, cancels with xy, leaving us with an answer, a very tidy answer, of 1 over y plus x.
So grade 10s, how are you feeling about that? It was good, right? It looked terrible, but we broke it down by choosing the most horrible parts to look at and dealing with those ones first. Okay, the next question comes from the number patterns exercise. Let's take a look. Okay, look at this pattern of hexagons, and determine how many hexagons, there will be in the 10th pattern. So this is obviously pattern number 1, pattern number 2, and pattern number 3. So we need to figure out how many hexagons there will be in pattern number 10. Now the interesting thing is that it hasn't told us what type of method to use. So let's just fiddle with it a little bit. Now when I first saw this, the black hexagons confused me a little, because in my mind this number 1 should be this hexagon over there. But suddenly it changed color. And then over here it changed color again. I couldn't cope with that. So in my mind I colored them in. Let's use pink for those. And then for the ones that are added in pattern 2, I'm going to use purple. So that's 4, 5, and 6 that were added in pattern 2. Let's color them in over here. 1, 2, 3, 4, 5, 6, and let's use green to color in the ones that are added in number 3. 1, 2, 3, 4, 5, 6. Oh, I see a pattern. In each one, we're adding 6 hexagons. So we have a common difference between each one of 6 hexagons. Now, grade 10s, that means that we need to use that 6 somewhere in the general term. And the general term will then help us to calculate how many hexagons would be in the 10th one. It's very possible for you to take out your calculator and carry on adding 6 until you get to the 10th pattern. But from a maths teacher's point of view, we really want you to demonstrate that you are able to take something like a picture of hexagons, turn it into algebra, and then solve for it afterwards. So I'm going to show you how to do that. Okay, and I'm going to start by writing down, drawing my table. And you'll remember that I did a table in the number patterns work as well. The table will contain the number of terms plus the value of the terms. So n, and we've got pattern number 1, pattern number 2, and pattern number 3, and the value of the terms. In the first pattern, we had 1 hexagon, then 7, then
13. So it is increasing
In sixes.
there, plus 6, and there, plus 6. What if we were to multiply n by 6? What answer would we get? Well, in the first one, we would get an answer of 6. Does that match up? No, it doesn't. So something needs to be changed. What can be changed to this to make it equal to 1? How about we subtract 5? Let's see if that works. So we've got 6 times by 1 minus 5. Does it give us an answer of 1? Yes, it does. So that's a smiley face. Let's try it with 2. 6 times by 2 is going to be 12, minus 5 is going to be 7. This number pattern will work very nicely. Now you might have got to this number pattern using other methods. Like for example, you could have said that the first term is equals to 1 and the difference is equals to 6. Therefore, and you might have done this method in class, it's going to be 1 plus 6n minus 1. Then you would multiply it out and you would get an answer of 6n minus 6, giving you 6n minus 5. Either way, it's all good. But the question wasn't asking for that. The question was asking for the 10th pattern. So I'm going to substitute 10n for n. So wherever there's an n, I replace it with 10, and that will give me an answer of, and I can calculate this in my head. Are you impressed? Which gives me 55. Okay.
So, grade 10s. That's the answer for that question. Shall we take a look at the next one? I'm sure this one wasn't really that challenging at all for you. The next questions come from equations and inequalities. Okay, and it says solve for x. Now, it's a little bit abstract, isn't it? We've got ax minus bx is greater than 2a minus 2b. And then it has all of these other inequalities. So let's take away all of this and talk about a and b as values. Okay, let's say I've got a in my right hand and b in my left hand. If a is bigger than b, it means that it's going to be a bigger number. That means if I say a minus b, what kind of answer am I going to get? Will it be positive or negative? And that's the mind shift that needs to happen here. So think about it. If a is bigger and b is smaller, then a minus b will give me a positive number. But if a is smaller and b is bigger, so if a is 2 and b is 7, 2 minus 7 is going to give me minus 5, so that will be a negative answer. And the reason why that's important is because the only thing that's different about an inequality in an equation is when we divide or multiply by a negative number, the sign changes direction. So that's where this question's going. It's wanting to test that kind of understanding. Now the last part of this question says if a is equals to b. And that means a has exactly the same value as b. So a minus b, 5 minus 5 gives you what answer? 0. So that one will be quite interesting to do. We're going to do this after you've had a breath of fresh air, a drink of water. I look forward to seeing you just now. Welcome back. Are you feeling relaxed? Now this question that we're about to do is the same one we were talking about just now. And it is a little bit abstract. In fact, I would say it's very abstract. And for some of you, it's going to be difficult to grasp. But remember what I said about a bigger number minus a smaller number, and a smaller number minus a bigger number, and the same number minus itself. And that will make it a lot easier. So let's look back at the inequality. The original inequality said ax minus bx is greater than 2a minus 2b. Now, I don't really like it the way it is, so I'm going to play with it, because maths is all about making it easier for myself. And I'm going to take out a common factor of x, giving me a minus b. And then on the other side, I'll take out a common factor of 2, giving me a minus b. So now this makes it a lot easier to deal with. Remember what we were talking about with bigger numbers minus smaller numbers. Okay, before we go on with this, I want to get to a new page where we have more space to play. Whoopsie. No, this is the page we're going to use. So in the first one, where a is more than b, what kind of answer will this give us? Let's say it's going to be 5 minus 2. What would that answer be? It's going to be 3. So that means I'm always going to get a positive number when a is bigger than b. And the reason why that's important is because I need to get rid of the a minus b by dividing both sides by it. And if it had been a negative number, the direction of my inequality sign would change. But it's a positive number, so the direction remains the same. And I'm just going to put these over each other nicely, because then they will cancel out, and I am left with x is more than 2. And that will be my answer for A. Okay, grade 10s. Now that you've seen how the first one is done, do you want to retry doing the other two? I'm going to give you a minute to look at them again and see if you can figure out how they're done. Now remember, in this first one, a minus b resulted in a positive number. So what do you think is going to happen in the second and the third? Let's scroll back and put a minute on the clock. On your marks, get set, go. Are you feeling more confident? Okay, well, let's see how you did. Now, I'm going to just get rid of everything that's here because it's a bit of a mess and I want to focus. And I'm going to rewrite it. And we took out a common factor of x and we had a minus b. It's greater than, and then 2a minus b. And in the second one, a is going to have a smaller value than b. So let's say a was 2 and b was 5. What would the answer be? It would be negative 3. So that means we're always going to get a negative answer. What happens when we divide
inequalities by negative numbers. The sign changes direction. So now it's changed direction, and we're going to cancel these, which means that x is going to be less than 2.
Grade 10s, I realize it's a little bit difficult to see this without real values, and that's the reason it's classified as a difficult problem, because you have to be able to think about what could possibly be happening if values were there. And that's why, as one of my strategies, I put values in so that I can see, is it going to give me a negative answer? Is it going to give me a positive answer? And then I can move my inequality sign as it is appropriate. Okay, the last one was quite interesting. And you're going to look at the answer and go, really? So let's take a look. Firstly, let's get rid of all of this mess, and this mess as well. Okay, and I'm going to rewrite it as x, a minus b greater than 2a minus b. Now, if a is equals to b, what answer would we get? We'd get an answer of 0. So that means we've got x times by 0 is greater than 2 times by 0. Oh, grade 10s. This opens up quite a debate, because if it was equals, we could have said that x can be any real number. But now the problem is that 0 can't be bigger than 0, can it? So 0 on one side is not bigger than 0 on the other side. So does this work? Is there any value for x that will work? No, there isn't. And that's why it requires a little bit of thinking out of the box to get it. Okay, let's go to the next one. And it's the last one for today. Trigonometry. Find the distance between the two buildings and the height of the taller building. So I need to find this distance, and I need to find the height of this. Okay, the way the question is phrased has given me a clue about what I need to do first. I first need to look at the distance that is happening over here. Let's just take away that. Now the problem is, they haven't actually drawn a triangle there. They've only drawn a triangle here. And that upsets me. In grade 10s, this is a common exam strategy. What they'll do is they'll draw a triangle in one part and expect you to see the triangle on the other side. But it wasn't there to begin with. I had to draw it in. So by doing lots of practice with these kinds of questions, I can then notice when the triangle hasn't been drawn in and draw it in anyway myself. Okay, let me show you what I mean. So we have this triangle that's over here. Obviously, this distance over here is the same as this one over here. So let's call this distance a distance of x. Actually, I suppose I can work with this other triangle, can't I? It's still the distance between the two buildings. Have I been given any other information? Yes, I've been given the height of 42 meters. Is this line the whole way across a height of 42 meters? The answer is yes, it is, which means that this side over here is going to be 42, and maybe I should move it just to the side over here where we can see it. So if we draw our little Helen, there we go. If we draw our little Helen, she's going to be looking opposite. Oh, that's right in the hypotenuse. There's the opposite, and here's the adjacent. So which one are we going to use? We're going to use tan, because tan
is opposite over adjacent. So tan of 38 degrees is equals to 42 over x. Okay, and now I need to do a little bit of mathematics, because the x, I need to get that x alone. And the only way I can get it alone is by shifting her around a little bit. So I'm going to multiply both sides by x, giving me, let's get rid of that, x times by tan of 38 degrees is equals to 42. And now I can get rid of the tan of 38 degrees. So it required a bit of forward planning on my part, but I get there. 42 divided by tan of 38 degrees. And I don't know about you, but I can't do this in my head. So I'm going to call up my friend, the calculator, and let's put it in. 42 over tan of 38 degrees, close the brackets, and we press equals, and it's 53,76 meters. Let's write that down. So x is equals to 53,76 meters. Now I'm going to do myself a favor and write it in over here as well, because I'm pretty sure I will need it. Did I write it down? 53,76, yes. I'm pretty sure I will need it for the next question. And the next question asked us to calculate the height of the taller building. So now that I've made some space, let's look. I know from there to there is going to be 42 meters. But I need to know what's going to happen over here. So what do I do? Okay, now grade 10s, when you look at this problem, you could look at it and you could see that yes, there is a 90-degree angle. That 38 plus that 52 does give me, does it? Yes, it gives me 90 degrees. But then I don't know the size of either of the lines, any of the lines. So that's not going to really help me. Do you remember that first triangle we looked at in the trigonometry lesson, where there were two triangles within a bigger triangle? We've got the same kind of thing happening here. We've got a triangle at the bottom and a triangle at the top, and both of them have a right angle, so we can use trig with both of them. So let's go back and look at that other triangle. Okay, and let's do it in pink. We'll highlight it. There it is. It has an angle of 52 degrees, so I'm going to draw little Helen over there, and a length of 53,76. I need to find out what this length is. Let's call it A, just because. Here's my hypotenuse. No, let's not call it A, because then it gets confusing. Let's call it P. Okay, P in relation to me is opposite. And the 53,76 is adjacent. So that means in the trig ratios, I'm going to use tan again. Let's write down what I need to. So I've got tan of 52 degrees is equals to opposite, which I named P, over adjacent, which is 53,76. And now I need to solve for P. That's very easy to do. All I'm going to do is take the 53 to the other side. 53,76, multiply tan by it. Tan of 52 degrees is equals to P. Okay,
So now, because we are not superhuman, we're going to take out the calculator, click again, there we go, move it over, and let's type it in. 53.76 times by tan of 52 degrees, let's close the brackets, is equals to 68.81. So P is equals to 68.81. Let me just check that I remembered that correctly. I did. Now, are we done? You might think yes, we are, but no. All we've calculated is this part over here. How do I find the length of the whole building? Well, obviously, I need to add that distance to this distance. So let's write that down. Therefore, the height of the building is equals to 42 plus 68.81. And let's use our calculator just to make sure that I don't make a mistake. There's no shame in using a calculator for simple things. So let's move this over. 68.81 plus 42 gives me an answer of 110.81. Okay, so that means it is 110.81 meters tall. Grade 10s, it's almost time for you to go away on holidays, and more than likely you're not going away, you're just hanging around, but you are relaxing. Now, I am a firm believer in making sure that you get proper rest. So here is my advice to you. Choose the days that you are going to work in the holidays. You do need to do work. If you want to carry on succeeding in maths, you have to keep exercising your brain. So choose them and only work on those days. But when you get to those days, make sure that you do work. All of the rest of the days, pack away your books. And when you're working on your maths, I want to see your pen in your hand and writing on the paper. Grade 10s, it has been a pleasure being with you this term, and I look forward to seeing you soon. Goodbye.